George is the science boy.
George Boyd, the science guy.
George
Boyd, the science guy.
Science rules.
George Boyd, the science guy.
Inertia is a property of matter.
George Boyd, the science guy.
Boyd is the science boy.
Boyd.
Hi everyone. Today we're going to talk about land breezes and sea breezes. In this chapter there are two main types of wind that we're going to discuss. One is planetary wind, which on a very large scale, due to uneven heating of the earth, moves air masses around. Those are high and low pressure air masses that we previously discussed, and they bring certain types of weather with them and certain wind patterns. On a smaller scale, locally, we have land breezes and sea breezes, and we experience this because we live on the coast. What happens is, because of specific heat differences, let me bring up the chart from the reference table. Because liquid water has a specific heat of 4.18, and the land, which is mostly made of granite, has a specific heat of 0.79. That's the continents. Remember, the continents are granitic and the oceanic floor is basaltic. So what I do is I use this number as a general number for the continents, and this is liquid water up here. Now water, because it has a high specific heat, heats up very slowly and cools down very slowly. Granite has a lower specific heat. It heats up quickly and cools quickly. Throughout the day, these surfaces are going to heat and cool at different rates. What that's going to do is create uneven air pressure and cause winds. Now, what I'm going to do is I'm going to close this out, okay, and bring up a picture of what's going on during the day. Now, during the day, what happens is incoming solar radiation from the sun, okay, comes down, okay, radiation, and when it hits the surface of the earth, it's absorbed. When it's absorbed, it gets re-radiated as long infrared heat, and that's what heats our atmosphere. So what happens is this electromagnetic energy coming from the sun, traveling by radiation, that's one of the three methods of energy transfer, hits the ground. Some of it gets reflected, that's why we see it. Some of it gets absorbed. The energy that gets absorbed speeds up the molecules. The molecules then give off energy, okay, to the atmosphere. And what happens is, over the hot surface, which is the land, okay, land during the day is hot, we get air expanding and rising. So the molecules are speeding up, the air expands, becomes less dense, and it goes upward. Over the water, which is relatively cooler than the land during the day, the molecules are slowing down, becoming more dense, and sinking. So what happens is, over the water during the day you get sinking air, over the land you get rising air. Now the air that's sinking has to be replaced by something. What it gets replaced by is the air that was rising over in this location. So in the upper atmosphere we have air traveling in this direction, and down at the surface, which is what we experience, we have air traveling in this direction. What this created was a convection cell, the transfer of energy due to density differences. And wind, for us, is always labeled based on what's going on at ground level, because that's what we experience. So at ground level right here, the wind is blowing from the sea to the land. This is called a sea breeze. That's one particular type of local wind. Now what we'll do is we'll take a look at the other extreme. Now at night, what happens is good absorbers are good radiators. So if the land heats up very quickly, it's going to cool very quickly. So now, relative to the water, this is going to be the cool surface. See, temperature is a relative thing. You could have something that's 90 degrees and something else that's 200 degrees and 90 is cold. You could have something that's 30 degrees and something that's 50 degrees and 50 degrees is warm. So temperature is a relative thing. So the land relative to the water is going to be cooler. The water has a high specific heat. It heats up slowly, cools down slowly. So now this is retaining heat from the day. So this is hot. See, our heat source, the moon is up now. The sun's gone. Our heat source is gone. So the only heat that these substances have is whatever they retain from during the day. Now, once again, over the cool surface, we get air sinking. Over the hot surface, we get air expanding and rising. The air over here has to be replaced by something. So it travels in this direction in the upper atmosphere. Down at ground level, we have air moving in this direction. And of these two, the wind is always labeled based on what's going on at ground level, because that's what we experience. So it's going from the land to the sea, so this is called a land breeze. Okay, so these are the two examples of local winds, land breezes and sea breezes.